Picture this, you wake up to a world buzzing with news that's not just extraordinary, it's otherworldly. On July 1st, 2025, astronomers in Chile peering through the Atlas telescope spotted a faint streak slicing across the Milky Way. This wasn't just another comet or asteroid, this was something far stranger, moving at a staggering 137,000 miles per hour, faster than anything humanity has ever launched into space. Named 3I/Atlas, it's only the third confirmed interstellar object to visit our solar system, and its arrival has sent shockwaves through the scientific community. Why? Because this cosmic wanderer defies every rule we thought we knew about the universe. Its chemistry, its speed, its very existence hint at origins so alien they challenge our understanding of the cosmos. Buckle up, because the story of 3I/Atlas is a wild ride through deep space, deep time, and the deepest questions about our place in the universe. Let's dive in and uncover what makes this visitor so terrifyingly unique, and why it's got the world's top minds on edge. It was a clear night in Chile when the ATLAS telescope, perched high in the Andes, caught that first fleeting glimpse. A streak of light, barely noticeable against the star-strewn backdrop, triggered an alert that would soon ripple across the globe. Within hours, astronomers from Hawaii to South Africa were on high alert, their telescopes swiveling to track this mysterious object. The data poured in, and the verdict was unanimous. 3I/Atlas was no ordinary space rock, moving at over 137,000 miles per hour, 55 times faster than a bullet. It was too fast to be bound by the sun's gravity. This was a true interstellar traveler, only the third of its kind ever observed, following the enigmatic Oumuamua in 2017 and the comet-like Borisov in 2019. But 3I/Atlas wasn't just another rare visitor. Its speed, its path, and its chemistry were unlike anything astronomers had seen before, sparking a global race to uncover its secrets before it vanished back into the void. Imagine the thrill of that moment. Scientists around the world, from dusty observatories to high-tech labs, united in a shared sense of awe. This wasn't just a discovery, it was a chance to touch the unknown. 3I/Atlas, with its hyperbolic trajectory, was cutting straight through our solar system, unbound by the forces that keep planets and comets in orbit. It was a one-way traveler, destined to slip away forever. Its name, 3I for Third Interstellar, carried the weight of history. Oumuamua, a cigar-shaped enigma, had slipped through our grasp before we could fully understand it. Borisov, though better studied, left lingering questions about its alien chemistry. Now, 3I/Atlas was here, bigger, faster, and stranger, demanding answers in a cosmic game of catch me if you can. Let's put 3I/Atlas's speed into perspective. At 137,000 miles per hour, it could cross the distance from New York to Los Angeles in under 2 minutes. That's not just fast, it's mind-bending. NASA's Parker Solar Probe, the fastest human-made object ever, maxes out at 430,000 miles per hour near the sun, but it took years and precise engineering to get there. Just 3I/Atlas question mark. It's been hurtling through space at this velocity for eons, untethered, unstoppable. Astronomers call this hyperbolic excess velocity, a term that sounds dry but carries profound implications. This object isn't just passing through our solar system, it's escaping it, immune to the sun's gravitational pull. In the time it takes you to read this sentence, 3I/Atlas has already traveled farther than the width of Manhattan. This speed isn't just a number, it's a clue. Nothing in our solar system moves like this. Planets, asteroids, comets, they're all tethered to the sun, orbiting in predictable paths. But 3I/Atlas follows a hyperbolic arc, a trajectory that screams of origins far beyond our cosmic neighborhood. To reach such speeds, it must have been flung from another star system, perhaps by the chaos of a planetary collision or the gravitational upheaval of a dying star. The energy behind its motion is staggering. If it were to strike a planet, the impact would dwarf the largest nuclear explosions in human history. Thankfully, its path keeps it safely distant from Earth, but the raw power of its velocity is enough to make even the most seasoned astronomers pause. What kind of cataclysm could launch a mountain-sized object across the galaxy with such force? The answer lies somewhere in the stars, and 3I/Atlas is our only clue. As telescopes tracked 3I/Atlas across the night sky, the real shock came not from its speed, but from its composition. In August 2025, the James Webb Space Telescope delivered a spectral readout that left scientists stunned. Most comets, when heated by the sun, release water vapor as their primary gas, with carbon dioxide, CO2, playing a supporting role. But 3I/Atlas, its spectrum was dominated by CO2, 8 times more than water. To put that in numbers, it's venting 129 kilograms of CO2 per second compared to just 16 kilograms of water. That's an 8-to-1 ratio, a chemical anomaly never seen in any comet, whether from our solar system or beyond. It's as if 3I/Atlas was born in a place where the rules of chemistry were rewritten. This wasn't just a quirk, it was a challenge to everything we know about comets. In our solar system, water ice forms farther from a star than CO2 ice, so comets typically carry more water. But 3I/Atlas's lopsided ratio suggests it formed in an environment unlike anything we've modeled, perhaps around a hotter, more massive star, or in a region bombarded by cosmic rays that stripped away water over billions of years. The James Webb team, led by Martin Cordiner, ran through every possible scenario, from exotic ice lines to supernova radiation, but none fully explained the data. This object was hinting at a birthplace so alien it could rewrite our understanding of how planetary systems form across the galaxy. Then came another bombshell. In July 2025, the Very Large Telescope in Chile detected something even stranger: nickel emissions without a trace of iron. In our solar system, nickel and iron are cosmic twins, forged together in supernovae and released together when comets heat up. But 3I/Atlas was streaming 5 grams of nickel per second with no iron in sight. This defied every known model of comet chemistry. Some researchers speculated about exotic compounds, like nickel tetracarbonyl, breaking down at unusual temperatures. Others wondered if billions of years in deep space had altered its surface, stripping away iron and leaving nickel behind. Even the timing was off. Nickel appeared before cyanide gas, flipping the usual sequence of comet outgassing. Each new spectrum deepened the mystery, painting 3I/Atlas as a relic from a cosmos we don't yet understand. The strangeness didn't stop with chemistry. When Harvard astronomer Avi Loeb and his team plotted 3I/Atlas's trajectory, they uncovered a path that seemed almost too precise. The object is set to pass within 0.19 astronomical units, AU, of Mars on October 3rd, 2025, about 29 million kilometers. A month later, it swings within 0.65 astronomical units of Venus, and by March 2026, it comes within 0.36 astronomical units of Jupiter. These aren't just casual flybys. In cosmic terms, they're near misses. The odds of a random interstellar object passing so close to 3 major planets? A mere 0.005%, or 1 in 20,000. To put that in perspective, it's like throwing a dart from space and hitting a bullseye the size of a coin. This trajectory feels eerily familiar to anyone who's studied space exploration. NASA's Voyager and New Horizons missions use gravity assists to slingshot spacecraft past planets, conserving fuel while boosting speed. 3I/Atlas's path looks like a natural version of this, perfectly aligned to skim Mars, Venus, and Jupiter in quick succession. Loeb's team didn't claim it was intentional, but they couldn't ignore the implications. If something, or someone, wanted to send a probe through our solar system, this is the path they'd choose. Adding to the intrigue, 3I/Atlas's closest approach to the sun happens behind it, hidden from Earth's view, making it impossible to observe during its most active phase. Is this a cosmic coincidence, or does it hint at something more? The numbers don't lie, but they don't tell the whole story either. The arrival of 3I/Atlas isn't just a scientific event, it's a human one, stirring instincts that have haunted us for centuries. In 1910, when Earth passed through the tail of Halley's Comet, panic swept the globe. Newspapers warned of cyanogen gas poisoning the air. In Chicago, people bought gas masks. In Texas, vendors sold anti-comet pills. In Paris, department stores peddled comet-proof umbrellas. While in Haiti, a voodoo doctor hawked elixirs. The fear wasn't just superstition, it was rooted in the unknown. 2 years earlier, in 1908, the Tunguska event had shown the sky's power. A fireball exploded over Siberia, flattening 830 square miles of forest with the force of 30 megatons of TNT. No crater was found, but the devastation lingered in the public psyche, a reminder that the cosmos could strike without warning. Centuries earlier, comets were omens of doom. In medieval Europe, over 400 illustrated broadsheets from 1550 to 1659 chronicled fiery apparitions in the sky, linking them to wars, famines, and fallen kings. The comet of 1577, with its sword-shaped tail, sparked mass prayers in Nuremberg. In 837 CE, China's Tang dynasty recorded a comet as a portent of rebellion, prompting rituals to appease the heavens. From Aztec codices to Polish chronicles, every culture saw these visitors as messages from the cosmos, often laced with dread. Even as science advanced, the awe remained. When 3I/Atlas appeared, it tapped into that same primal instinct, a mix of wonder and unease that makes us question our place in a universe far larger than ourselves. To understand 3I/Atlas's true significance, we need to look beyond its speed and chemistry to its origins. Using the Gaia star catalog, astronomers traced its path back to the Milky Way's thick disk, a region of ancient stars, up to 10 billion years old from the galaxy's chaotic youth. With an inclination of 175 degrees, 3I/Atlas dives through our solar system at an angle no local object could match. Its velocity and trajectory suggest it was ejected from a star system long before our sun was born, perhaps during a violent collision or planetary migration. Simulations by Oxford's Chris Lintott and Matthew Hopkins give it a 2/3 chance of being older than our solar system, potentially 7 billion years old. This isn't just a rock, it's a time capsule from the galaxy's formative years. Imagine that for a moment. When 3I/Atlas began its journey, Earth didn't exist. The sun was just a cloud of gas and dust. This object has drifted through the galaxy for eons, witnessing the birth and death of stars, carrying the chemical scars of a vanished world. Its CO2 heavy composition and nickel anomaly hint at a birthplace unlike anything in our solar system. A star system with different physics, different chemistry, perhaps even different rules. As it races past Mars, Venus, and Jupiter, it's not just a visitor, it's a survivor, a relic from a time when the Milky Way was still taking shape. Every data point we collect is a glimpse into that ancient past, a chance to read a message written before life on Earth began. As 3I/Atlas captured the world's attention, the internet erupted with speculation. Viral headlines screamed of terrifying warnings and secrets NASA won't admit, racking up millions of views. But behind the clickbait, a troubling gap emerged. The real science, raw spectra, orbital models, chemical anomalies, was drowned out by a flood of recycled footage and AI-generated narration. Michio Kaku, a physicist known for making the cosmos accessible, was often quoted, but many of these quotes were fabricated, stitched together from unrelated interviews. The Atlas team, led by Larry Deno and John Tonry, never spoke to these channels, yet their work was co-opted into narratives of alien probes and existential threats. The result? A credibility gap that threatened to bury the truth. This isn't new. When Oumuamua appeared in 2017, similar stories flooded the web, blending fact with fiction. But with 3I/Atlas, the stakes feel higher. Its anomalies, CO2 dominance, missing iron, improbable trajectory demand rigorous debate, not sensationalism. Harvard's Avi Loeb, no stranger to controversy, has called for open inquiry, but even his measured speculation struggled to break through the noise. The challenge is clear. In an age of viral content, how do we separate signal from static? The real story of 3I/Atlas isn't about fear-mongering. It's about a universe that keeps surprising us, forcing us to rethink what's possible. The deeper scientists delve into 3I/Atlas, the more it feels like staring into the abyss of cosmic history. Its chemical oddities and breakneck speed are only part of the puzzle. The object's very existence challenges our assumptions about the galaxy's structure. The thick disk, where 3I/Atlas likely originated, is a graveyard of ancient stars, some formed when the universe was less than a third of its current age. These stars, metal-poor and scattered, tell a story of a younger, more chaotic Milky Way, where violent collisions and gravitational tugs shaped the galaxy's earliest chapters. 3I/Atlas, with its steep 175-degree inclination and 58 kilometers per second excess velocity, carries the scars of that turbulent era. It's not just a visitor, it's a fossil, a fragment of a star system that may no longer exist, flung into the void by forces we can only imagine. As astronomers piece together its story, they're not just studying an object, they're reconstructing a chapter of the galaxy's biography, written in ice, rock, and cosmic dust. The arrival of 3I/Atlas has done more than spark scientific debate. It's reignited humanity's age-old quest for meaning in the cosmos. Across history, from ancient China to medieval Europe, celestial visitors have been more than objects. They've been symbols, omens, and mysteries that force us to confront our place in the universe. Today, we trade broadsheets for social media, but the impulse remains. 3I/Atlas, with its alien chemistry and improbable path, stirs that same sense of wonder and unease. Are we alone? Is this a random traveler, or does its precision hint at something deliberate? These questions, fueled by data and amplified by speculation, pull us into a dialogue that transcends borders and generations. The object's fleeting visit, gone in months, never to return, reminds us of our brief window to grapple with the infinite, to find meaning in a universe that doesn't speak our language but demands our attention. As 3I/Atlas speeds toward its exit, it leaves behind a legacy that's both humbling and exhilarating. Its presence has united scientists in a global chase, from the ATLAS team in Chile to the analysts poring over Gaia's star maps. It's forced us to rethink comets, star systems, and the very fabric of the galaxy. But beyond the data, it's a reminder of humanity's audacity to build tools that can track a speck of ancient ice across billions of years, to ask questions of a universe that owes us no answers. 3I/Atlas is a bridge between the ancient and the modern, between the chaos of the galaxy's birth and the curiosity of a species just beginning to explore. As it fades into the dark, it leaves us with a challenge: to keep looking, to keep questioning, to keep chasing the mysteries that remind us how vast, how strange, how beautiful the cosmos truly is. The story of 3I/Atlas is more than a scientific saga. It's a dance with the infinite, a fleeting encounter that forces us to confront the scale of the universe. Its journey, spanning billions of years and countless light years, dwarfs every human achievement, yet here we are, tracking its path with instruments of our own making. The object's alien chemistry, CO2 dominating water, nickel without iron, hints at processes that may have shaped worlds we'll never see. Its trajectory, skimming 3 planets with improbable precision, feels like a cosmic choreography, a pattern that teases the edge of intent. Whether it's a random wanderer or something more, 3I/Atlas invites us to imagine a galaxy teeming with possibilities, where every star system holds secrets waiting to be uncovered. This visitor, born before our sun, is a reminder that the universe is not just vast, but alive with stories, each one a thread in the tapestry of existence. What makes 3I/Atlas so compelling isn't just its strangeness, but the way it pulls us out of our everyday lives and into the grand sweep of cosmic time. For a moment, we're not just people scrolling through feeds or rushing through our days. We're witnesses to a relic from the galaxy's dawn, a messenger from a time before Earth was born. Its presence challenges us to look beyond the mundane, to ask questions that stretch our minds to breaking. How many other wanderers are out there, drifting between stars? What stories do they carry, and what does it mean that we, a species so young, can catch even a glimpse of their journey? 3I/Atlas is a call to wonder, a reminder that the universe is not just a backdrop, but a living, breathing mystery that invites us to explore, to dream, and to never stop asking what lies beyond. As 3I/Atlas races toward its exit from our solar system, it leaves us with more questions than answers. Where did it come from? What forged its strange chemistry? Is its path a cosmic fluke, or does it hint at patterns we can't yet see? The data is undeniable: a speed of 137,000 miles per hour, an 8:1 CO2 to water ratio, nickel without iron, a trajectory that defies the odds. Yet the scientific consensus remains cautious, urging us to marvel at the mystery without jumping to conclusions. This object, older than Earth itself, is a reminder of how much we still don't know about our cosmic neighborhood. But there's beauty in that uncertainty. For a fleeting moment, humanity has caught a glimpse of something ancient, something alien, passing through our sky. We've built telescopes to track it, spectrometers to decode it, and models to trace its path across billions of years. The same species that once feared comets as omens now chases them with science, turning dread into discovery. 3I/Atlas will soon vanish into the interstellar void, but its legacy will linger. It's a call to keep looking up, to keep questioning, to keep exploring a universe that's vast, strange, and endlessly surprising. So what do you think? Is 3I/Atlas just a cosmic coincidence, or does it carry a deeper message? Drop your thoughts in the comments below, and let's keep this conversation going. If this story of a galactic wanderer sparked your curiosity, give this a like and share it with someone who loves a good mystery. The universe is full of secrets. Let's uncover them together.